Before we get to debugging slash in the Spyder IDE, let's talk about good programming techniques and one of the main things that we need in order to do a gradient descent algorithm, because you'll see that we're getting to the gradient descent algorithm next class, but we're going to debug some stuff today and we're going to use the Spyder IDE. But before we do that, let's talk about some good coding fundamentals. And this one in blue, I'll probably say in class, I'll say it multiple times. Start small. Now, I didn't in this particular video, so just understand that I did this on purpose. I would never just code out this thing the way when we get over to our example in Spyder, we'll see that there's a lot of mistakes in there. And to be honest with you, I just coded it up the way without using any sort of incremental steps. And this is the code that came out. So we're gonna undo all my mistakes together. Okay, so the first thing you need to do when you're going to code some sort of thing that you want to do is you got to understand the problem. And I also say you need to decompose the problem and find the smallest little tidbit that you can work out that you don't have to worry about anymore. So once you understand the entire problem, you can then look and go, okay, well, if I can do this small thing, it will help us solve the big picture. And so the example that I'm using today is to find the gradient, a numerical estimation of a gradient, regardless of the number of dimensions. So in this case, this is a two-dimensional idea, right? So 3 dimensions, if you think of it as coming off or into the paper, I should say, because these are going down. But suppose this were a contour map of this two-dimensional function, and then just recall what a gradient is. So it's that vector that if this is x naught, this is my starting point, then it's going to go in the direction that is orthogonal, especially if it's sitting there on, actually they're all sitting on a contour line slash level curve, but this is sitting on this level curve slash contour line, and it's going to be orthogonal in the direction of max increase, and the negative gradient, right, multiplied by the -1 times that vector points in the opposite direction, or the direction of max decrease. Now it's not pointing towards the middle, but it is pointing in that direction. So this negative gradient points in that direction. And it sounds like the fire alarm's going off, but I'm going to keep talking here for a little while, and I'll observe the video and see if it works, since we're about halfway into this bad boy. Okay, so the next thing you want to do for a good coding fundamental is you need to work out some examples. And so one example would be a very easy function, the square of the distance from any point out. So this is different than this contour plot, of course, but this is just a very simple function that we can take the derivative of and take the partial derivatives very easily, and we can probably visualize this thing pretty easily. And so that's why I'm using it. So the gradient of it is just 2x1. So you take the partial with respect to x1, and it's 2x1, and then you take the partial with respect to x2, and it's just 2x2. And if I put in 3,2 in here, this is symbolically what the answer should be, 6,4. 6,4 should be, if I put in 3,2 into this function, and we can keep going with this one as well. I mean, this is the function that we programmed up last time, and we'll keep that thing. But how do I do it? How do I estimate this thing? How do I use numerical method in order to do it? Well, from the definition of what a partial derivative is, right? So if you go back in your calculus text and go, well, what are we doing when we do a partial derivative? All you're doing is you're holding one constant, or one variable constant, or you're holding every variable constant except for 1. So the only variable that I'm changing it is x1. x2 stays constant, x2 stays constant, and I'm moving it by plus h and then a minus h, where h is very, very, very small. And in the distance there, the delta x, if you will, so delta y over delta x, so the change in the function over the change in whatever the space was that the distance that you moved is that ratio. That's the derivative that we're talking about, and that would be the partial derivative. So, and then when you come down to the second component, right, all you would do is just add the h's to the second component, and then we divide by 2h, and then this would be an estimate for the partial derivatives, which would be the gradient. If you put them together in this vector form, it would be the gradient. Okay, I claim that you need to understand this in order to be able to catch the issues in my code. So let's just pop over to the code, and just recall from last video, this is just, so I'll restart the console. So just so we don't mess anything up. And I restart the console and I'm putting this function in. And then all I want to do now is show you what this does. This produces a vector of 10 zeros. So, and then I'm just going to print it off and you'll see, so 10, if we change this number to 3, then it'll be 3, and so on and so forth, right? So that's what's happening inside in here, right? So I'm going to find out how big A is, and I'm going to start off H being a bunch of zeros, and then I want to add this little bit of H to only one of the components, the ith component. All right. So what we're doing is, well, let's just hit the button. Let's hit the go button. All right, so this is just to show you that it gives us the same thing it did last time. And so I'll get rid of this. And I think 3.2 was the one we used a second ago, so we'll do 3.2. That's the example we worked out. And then we do it and we say, oh, we didn't run it yet. So we got to highlight the whole thing. And it says we're getting some kind of list. Object cannot be interpreted as an integer. Okay, so you might look at this thing and go, ugh, what is that thing talking about? And you might want to put a bunch of print statements in here, and that would work. Another way to do it is to use the Spyder. So you can put a breakpoint just by coming over here and I think it's double click, maybe, yeah, it's a double click, or it's a click until the little red button shows up here. So all I'm doing here is I'm putting a breakpoint in. And you come up here to debug and you hit debug, or I think you can even hit continue, but we'll do debug. And it tells you, oh, so it ran it all the way, so you can see where this is at, right? So we're here at line 16, and you can see that, and it's run all the way to here to the point where we put our breakpoint. And at this point, I don't think it's done anything, but we can print off. So this IPDB, this IPython debugger is what that stands for. And then you can do things like print, like you could type in print if you wanted to, or you could put print in, right? So if we want to print what n is and hit enter, you would get 2. So does that make sense? Well, we put in 3.2, so that makes sense that the length is 2. What is happening here? Well, this is where the error was at. So you can do then step through this thing, press S, and it will take you through, and that's when it tells you that, hey, this list object cannot be interpreted as an integer. So then you might want to say, what do we mean by that? Print A. What is A? Oh, A is a list. So does it make sense for range to be 3.2 with a container in there? And it doesn't. So that's telling you right now that that's where the error is at. So let's get out of it so we can stop it, and it'll come back out. And then we can leave the breakpoint in. And then the problem here is that we needed it to go to the number in, or the length of A. So either one of those two we could replace with what A is, and then we can rerun it. So we'll go back to debugger, hit debug, comes in, we can step in, and now it's getting in there. Now we can print I, and we know I is equal to 0, and we can step again. You can either do that, or you can come up here to debug and step with control F10. So if you wanted to do it with control F10, you could do that as well, and I'll do it with control F10, and it prints off. So then it prints off all of the stuff that's going on here, right? So if right now I want to see what vec is, I can do print h underscore vec f9, or enter, not f9, and all it's done is exactly what we wanted it to do. Remember, we wanted hvec to have this h, and h is equal to 1e to the negative 4, and so we're going to add a little bit onto the x component, and then I'm going to subtract a little bit of the x component, and then I want to evaluate it, right? So that's what we want this plus to be. I want to take a, and I want to add a little bit on the x, and then I want to take a, and I want to subtract a little bit of the x, and then I want to evaluate those two things, and then divide by 2h. So that's the idea that we want to do. And so let's step into it again. And then it says control F10. Just done that one, control F10. It says type error. So why does it say type error? So we got the minus, and then we're doing grad, so list, so print plus, oh, name error, plus is not defined. Okay, so let's exit out and run it again. So debug up to this. Actually, we could probably make it go all the way to, let's just step through. So we'll hit step, So HVEC was correct. That was correct. And then here's the problem. So plus, so print plus 3, 2, what in the world happened there? Is that what I wanted to do? So it said A plus A. Oh, I see what it did. Okay, so A was 3 comma 2, and then it plussed HVEC, so it put it added the vector. That's not what I wanted to do. I wanted to take a little bit off that guy and leave that one alone, right? Or, I'm sorry, add. So I wanted this to be 3. This plus should be 3.000 zeros and a 1 comma 2, but it didn't do that because I didn't do this correctly in here. And then what it probably said in here was this thing is no good. Type error for a minus, right? So there is no minus that goes along with, so there is no two, I can't subtract two things from a list. So I need to think about how to do this correctly, right? So I claim that there's a way to do it. So let's go ahead. Obviously, adding those two isn't correct. And so what we can do is we can say plus, so plus is equal to, and I'm going to list comprehend this thing. And I'm going to say AI plus H vec in range length range or in, since I've already done that one. This is where they said that. And then minus minus is equal to AI minus H vec I for I in range in. Let's find out if that worked. All right, so let me put the little guy here, and we'll rerun it. Ooh, it just gave us a bunch of zeros. Hold on. Let's find out. Oh, I need to debug. That's right. So we need to debug, and then it'll run it all the way to grad, right? So now I can print plus. I can print minus. Oh, so it's doing what I think it should do. And then it will even do this. It'll do f of plus, enter, and then print f of minus. Ooh, so we're getting good results here. And then I want to print, so that should be a very, very small number. So f minus f minus. Okay. And then print 2 times h. All right, so this number, so let's check it out. This number is 0.0012, and this number is 0002. So if I divided those two, this would be 1, 2, 3, 4, 1, 2, 3, 4. So the answer should be 6. So I don't know if you guys see that, but if you take this number and divide it into that, you got to move it over that main decimal places, so it ends up being 2 and a 12. So the answer should be 6. So let's see what this thing gives us. So step, oops, I don't want to step there. I'm going to step over here. I didn't want to step into it. Goodness. Control. All right, so let's find out what so print gradient. So it's a pretty small number, so that is not correct. It's not the 6 that I was expecting. And so what is the problem with, oh, I see. So the problem is we divided by 2 and then we multiply by h, and that's an issue. So I got a divide by this whole thing. And then I think it should be right. All right, so let's run it again. Let's go. I'm going to put the breakpoint there. I'm going to get out of there. I'm going to debug it, come all the way down to here. And then there's a place in debug. It's a step is control F10 step into. I don't want to step into it. That will make it so that it goes in and evaluates this thing. I just want to control F10. So control F10, and then it comes back up to 16 again. So that means it evaluated this thing. So that means that we can print gradient, and hopefully there's a 6 in there. Yes, so we got our 6. And we probably need to get rid of all this extra business here. That's probably just some sort of round off error. And then let's continue. So you can debug. Continue takes you all the way to the next breakpoint again, which would be back down here, or you could just step through it again. And then once we're here, we want to control F10 again, and that gets us back up here, and then it should exit out. It should be the last one, but before I do that, I want to print gradient. All right, so we got what I think is the answer, 6 and 4. Let's find out what it gives us. So control F10 and return. So what is the answer? So let me take out this breakpoint. Let's just run it. F9, F3. Oh, okay. So I'm returning A, even though it was given us. So gradient is what we want it to return. So let's highlight all this, F9, and it's returning everything that we think it should. All right, that is how we're going to do. So let's find out what happens. Just to make sure this thing's general enough. So if I put in 4, what would it do? And it looks like 2 times 4, right? So you could put in any number now, I think, any number of things in here, and this gradient function will calculate the gradient, or it'll estimate the gradient at that point for any number of dimensions. All right, that's all I got for this lesson. We will now put this gradient function, and we'll put all of this stuff together in the next lesson in order to do some sort of gradient descent.